this video, we will discuss example 6.3 that talks about the time required to charge a capacitor. Consider a circuit consisting of 12-volt battery, a 50 ohm resistor, and a 100 microfarad capacitor wired in series. The capacitor is initially completely discharged. The question is asking you, how long after the circuit is closed will it take to charge the capacitor to 90% of its maximum charge? Let's write down what is given to us. I have the potential difference of the battery, which is 12 volt. We have the resistance of the circuit, 50 ohm. The capacitance C, which is 100 microfarad. Microfarad, I will convert the unit. Micro is 10 to the power -6 farad. And they have said that how long, that means I need to find how much time it takes to charge the capacitor to 90% of its maximum value. So QT must be 90% of my Qmax. If you write charge at any given time must be 90% of maximum value, that means this charge must be 9500 of Qmax, or it should be 0.90 Qmax. So I can write Qt equals 0.90 Qmax. And when you take this ratio, Qt over Qmax equals 0.90. We will use this equation in the next part of the problem. Question wants me to find how long it will take. So it wants me to find T. We will use the equation for charging of capacitor. And the equation goes like this. Charge of the capacitor at any given time equals the maximum charge capacitor can hold, bracket, 1 minus e to the power -t over RC. I'm going to solve this equation to calculate T. So first divide by Qmax on both sides. You get Qt over Qmax equals 1 minus e to the power -t by RC. Qt over Qmax we already found is 0.9 equals -t by RC. Now we rearrange the term. We move -e to the other side and 0.9 over here. We get e to the power -t by RC. Since there was a negative sign here, when I move it to the other side, this negative will become positive. 1 positive, when I move it to the other side, will be subtracted. So you have e to the power -t RC equals 0.10. If I want to solve for this e, I need to use natural log on both sides. I need to take the natural log on both sides to get rid of that e. So we write natural log of e to the power -t by RC equals natural log of 0.10. Natural log of something raised to the power. The rule says that we can multiply by this power on the side and just write -t over RC natural log of e. Natural log of e is 1, so we get -t over RC equals 0.10. We rearrange this term and write t equals -RC natural log of 0.10. Now let's substitute what is given to us in the question. R is 50 ohm, capacitance is 100 microfarad, natural log of 0.10. And when you solve this, you get your time as 0.0115 seconds, which you can write as 11.5 milliseconds.